Hi, purpose of this video is to look at uSubstitution as it pertains to trigonometric functions. Trigonometry, all sorts of craziness happens, a little different from other functions, so it's worthwhile having exclusive content related to just trig and integration. Take, for example, the cotangent of x. Often you will see in formula packets and formula charts all over that the cotangent of x, or an integral, is predefined for you. But in case it's not, or in case you wonder where it comes from, it's just a uSubstitution problem. What we're going to do is flip this into cosine of x over sine of x, and then we're going to let u equal the sine of x. Therefore, the du equals the cosine of x dx, and so we can see the cosine of x dx becomes du in the denominator, in the numerator. Now we just integrate 1 over u du, which is the natural log of u plus c, and then all we have to do is put our u value back. So we get the natural log of the absolute value of the sine of x plus c. Just to make sure this is right, I want to point out the reminder that this is just a reverse chain rule. So if I was differentiating the natural log of the sine of x, I would start with 1 over the sine of x, and then I would multiply that by the derivative of the inside function, which is the cosine of x. So we're going to get cosine of x over sine of x, which is the cotangent. So all is well with the universe. Let's try something a little bit more interesting. Now I can see sine cubed of x and cosine squared of x, and the one thing I do know is that if I was to take the derivative of the sine cubed, I would have to chain rule it, and I would get 3 sine squared of x times the cosine of x, which doesn't match the cosine squared. So I'm going to have to be a little bit more creative here. Here's where experience and creativity come into play. What I'm first going to do is I'm going to express the sine cubed as the sine of x times the sine squared of x. So what you say? I say, well, let's take that sine squared of x and make it 1 minus the cosine of squared of x times the cosine squared of x times the sine of x dx. What did I do that for? Well, as you can see, now I have everything in terms of cosines right here, and the derivative of the cosine is the sine of x, so now I can actually let u be the cosine. Therefore, du is the opposite of the sine of x dx. So with my substitution, I'm going to take the negative. Sorry, I shouldn't have put that negative there right away. Get rid of that. And now I'm going to put in the negative 1 times the sine of x dx is going to become my du. And then we're going to have 1 minus u squared times u squared times du. So once again, don't forget the du is equal to the negative sine of x dx. I need to put the negative in front because here I only have a positive sine of x dx. We got the opposite here when we put in the du. Distributing the u squared now gives us a nice, easy to integrate expression. And don't forget to then distribute the negative in here, and we have our integral. Don't forget, again, put your u back where you found it, and we get 1/3 cosine cubed of x minus 1/5 cosine to the 5th of x plus c. I was delighted to go find, when I went on to Wolfram Alpha, that Wolfram did the uSubstitution in an identical fashion. So it seems like not only is this the Wolfram way, it's the only way that you would want to get this here integral. So I'm going fast because the expectation, of course, is you're pausing and rewinding when there's something that you don't get. Last issue, now we have the sine to the 4th power of x. What to do, what to do. So I'm going to make this the sine of squared of x squared. Well, this seems a little bit different than what I did before. What I did before is I broke up the sine of x, sine to the sine cubed of x. I broke it up into a bunch of different things. This time, though, I'm actually going to just square the sine squared. Here's the thing. There's this identity that is fundamentally important. It's the double angle identity for the cosine of 2x, and that gives you 1 minus 2 sine squared of x. Which means if you solve for the sine squared of x, you're going to get 1 minus the cosine of 2x over 2. So this is what we call a power-reducing formula, and what it does is it takes a trigonometric squared function and turns it into a non-squared trigonometric function. So this sine squared inside, I'm just going to replace it with all of this stuff. That, of course, is squared, and it's in terms of x. All of that, if I FOIL out the numerator, I'm going to get all this stuff up here. And then, of course, the 4 is because if I take 1/2 and square it, I get 1/4. So I took the 1/4 out. I FOILed out the numerator to get all of this stuff. And now I have, again, another issue because I have a cosine squared and a cosine, and what to do. Well, the cosine squared of 2x is equal to cosine of 4x plus 1 over 2. This is a modification of the same identity that I used, except this time it's going to be the cosine of 2x is equal to, well, let's see, I'll show you. Cosine of 4x is equal to 2 cosine squared of 2x minus 1. This is using the double angle identity, except the double angle is double 2x. Double 2x, you get 4x. So this gives us 2 cosine squared 2x minus 1. And then we can take solve for cosine squared of 2x, and that's how we got cosine of 4x plus 1 over 2. So here's the cosine of 4x, add the 1, divide by the 2, and that's what we get. That enables me now to express the 1/2 cosine of 4x plus 1 instead of the cosine squared. Now, somebody would be looking at this and saying, this is terrible. You've made things worse, not better. Look at how elegant sine to the 4th is, and look at how horrible your expression is. We have cosine of 2x and the cosine of 4x, and we have all sorts of stuff. So, what to do? Well, what I think is, because all of these are now in terms of singular powers of cosines, we can just anti-differentiate straight up, yo. First one, the cosine of 2x is going to integrate, the negative 2 cosine of 2x is going to integrate into negative 1 sine of 2x. Remember the reverse chain rule. We're going to divide the 2 by the 2, and that gives us what we have here. We're going to take the 1/2, divide that by another 4 to reverse the chain rule, so we get 1/8. And the antiderivative of cosine is sine. And so the antiderivative of 1 is x. And then, of course, I distributed the 1/2, so it's really the antiderivative of 1/2 is actually 1/2 x. And we got the 1/4 on the outside, so we'll just send that back in. We have 1x plus 1/2 x times 1/4, that's 3 halves x times a 4th is 3/8 x. And then we get 1/4 sine of 2x subtracted, and then we're going to add 1/32 sine of 4x plus c. And that, of course, if you ever wanted to know, you could check that out on Desmos. So, sorry if this was too wordy. Thanks for watching anyway, and have a great day.